So I talk about on this channel quite a lot, some of my favourite scientific theories and discoveries, and obviously my background is as an astrophysicist, so a lot of these occur in different galaxies, different planets, or even parallel universes. But actually, there's a lot of very interesting stuff that you can do with very little kit, very simple stuff, even stuff that's just simple Newtonian mechanics. And I wanted to talk to you about my most favourite one of those today, and that's chaos theory. Chaos theory is a branch of maths or physics that deals with nonlinear systems where very slight changes in initial starting conditions can create massive changes in the end states of those systems. Now, this might sound a little bit boring, but what I really wanted to introduce you is a very practical system that displays these effects, and that is the double pendulum. Now, a double pendulum, if you're mathematically inclined or you want to go study university physics or maths, you can solve quite simply using Hamiltonian mechanics and the Lagrangian. We don't have to talk about the technicalities here, but if you look at how the double pendulum works, when there's a small angular displacement, the pendulum acts very normally. It's a linear system. You can solve the equations, everything looks pretty ordinary and predictable, as you can see. However, when you have a large angle displacement, the motion of the pendulum is extremely unpredictable. What do I mean by that? It means that any tiny variation in that starting angle has a massive effect on how the pendulum moves, to the extent that it's very difficult to reproduce the same set of motion with two different starting conditions. This is chaos theory. The most famous example of this was the butterfly effect, where one of the original proponents of chaos theory, Lorentz, talked about the effect of a butterfly flapping its wings and causing a tornado somewhere else in America. He's talking about this precise effect, and in fact, weather systems are one of the most common places where chaos theory occurs. Highly nonlinear systems which are very, very sensitive to initial conditions. Why is this very interesting? Well, there are many things in the world really that are chaotic systems. The stock market is such an example, and many other physical systems exhibit these properties. It's interesting because as human beings, we often think that it's things like quantum mechanics, that means we can't predict the states of systems, but that's just not true. What's fascinating to me is that a system that can be described by simple Newtonian equations we can solve and fully understand, can still exhibit the properties of randomness, and can still fool us with very limited differences in initial conditions. That's both the beauty and the frustration of chaos theory.